Hello again, this is Mr. Bennett here, and I'm making a video for a former student of mine for a college class. And again, you see some of this stuff in high school as well as college. And the video, if you've already seen the first video, we worked out 1 through 4 and number 6, which you can kind of see in the top corner right there. I did not completely write out the problem for number 5, so we skipped it. So this is essentially part 2 of this video. Part 1, again, has the other 5 problems worked out, but we're going to do number 5 now. I kind of left out the problem there. That might help a little bit. So in the previous video, or part 1, I guess, we looked at what did it mean to be 1-to-1. And again, every y value has exactly one x value. In other words, any y value that shows up needs to be paired with only one x, right? Not 2 x's or 3 or 4 or an infinite number. And then these last 3 or 4 problems have dealt with inverses. And again, inverses is like, they are essentially functions, at least the ones we've seen so far, I believe. And inverses is almost looking at a function sort of backwards. We're not looking at what y value is produced with a certain x value. Rather, we're looking at what what x value is produced with a certain y value. And so think of it that way. Okay. But we may be able to clean this up a little bit instead of trying to do this all at one time. So to make this easier on ourselves, this is the inverse of the function, right, with an input of f of 1. Okay. Now you could start from the inside and work your way out, or you might can simplify this a little bit without having to start all the way from the inside. So we'll try to do both and see do we actually get the same thing. So I'm going to try it the way I was thinking we could do it. But again, there's typically or hopefully more than one way to do certain things, or many things in math. F of 1 is, what is the y value when x is 1? Well, that should be easy. We'll need to go back over here and look. Okay, when x is 1, what's the y value? Okay, well, x is 1 right there. So f of x is, okay, these are the y values associated with those x values, right? So if x is 1, what's y? Well, it's right there. It's 2. When I plug 1 into this, I get 2. When I plug 2 into this, I get 7. And 3 into this, I get 0. So, but we only want to look at 1. So when you plug 1 into here, you get 2. So really, all of this boils down to, sorry, I didn't mean to scratch it all out. All this boils down to is the inverse of that function when we plug in 2. Interesting. So f inverse of 2. Remember, this is not what is y when x is 2. This is what is x when y is 2. Well, we need to go back here. What is x when y? Remember, this is still the same thing as y. When y is 2. Well, there's only one y value in this chart. It's right there. I'm sorry, there's only one y value that is 2 in this chart, and it's right there. And then we need to find out, okay, what's the x value associated? Well, it's 1. So f inverse of 2 is 1. Interesting. Why is our result essentially the same thing as where we kind of started back here? Think of it as almost like 2 different operations, right? Where are we? Canceling each other out, right? I use canceling as like quotes, right? Why is that? Well, it's almost as if you're undoing a function just like you're undoing an operation. Why do we even undo operations in the first place? It's because we're applying the opposite function to them, essentially. Like, why are we able to undo multiplication? Well, we can use a division function, a function of division, or rather the operation, excuse me. Well, maybe there are some similarities as well with functions, and that is the case here. Anytime we want to take the inverse of a function, when the function is actually part of this input, you're actually going to undo it. So let's see if that's true. Now, I'm going to make this up, and I'm not sure if it's going to work or not, but let's see if it does. I'm going to make up a second little problem, and we're going to say, okay, what about, let's do this. I'm sorry, let me fix that just to kind of clarify and make sure there's nothing confusing about that. So I'm going to move that equals 1. It still equals 1. I'm just going to, didn't want you to think that's what that equals. Instead of looking at f inverse of f of 1, let's look at f of f inverse of 4 and see, do we get 4? Is this actually true, that statement I made earlier? Do those functions really undo each other, and whatever you have left inside here is your answer? Well, let's test that. f inverse of 4. That's not what is y when x is 4, but it's what is x when y is 4, again, because you're looking at the inverse. Well, when y is 4, well, where is y 4? Well, I actually see, I see now where I made a mistake. I'm sorry. I was looking at the x values. I'm sorry. I'm going to scratch that out. Let's do 5. I think that's what I had thought in my mind, but I make boo-boos all the time. Sorry. So what is x? Instead of this being what is y when x is 5, it's what is x when y is 5. Well, there's only one y value up here that's 5, right? Again, this is your column, or excuse me, this is your row for your y value. So when this is 5, right? So 5. So here we're looking at y values that are 5, okay? So we want to look at what x value is associated with this y value of 5. Okay, again, imagine plugging this in for y and seeing, okay, what x value is associated? Well, it's 4, right? And so this is really can be rewritten as f of 4. Remember, f inverse of 5 is 4. Or when y is 5, x is 4, and then there's your functions again. So notice now we're looking at a function that's not an inverse. That's your x value. This time we are looking at what the y value is when this is the x value. Okay, so now we need to look at the top row, right? When x is 4, remember there's no inverse here. It's just a function as it is. When x is 4, where is it? Oh, it's right there, right? When x is 4, what is y? Well, again, there's your y row or your f of x row. Well, it's 5. So it's almost as if, just like with this first one up here, the inverse and the function itself almost essentially cancel each other out, and you were just left with 1. Same thing here. It's almost like these two, f and its inverse, canceled each other out, and you were left with 5. That seems silly. It's like, well, why would you even do that? Well, I think this is to show you that functions sometimes operate in ways or behave in ways that opposite operations do. Multiplication and division, adding and subtracting. Exponents that power, and then exponent, or that are whole numbers or natural numbers, and then exponents that are fractions or roots rather. Okay, so really your answer back here, to answer the actual original question, your answer should be 1. That's it. So the f inverse of f of 1 is 1. Awesome. So let me know if you have any questions. Please leave a comment, and unless I turn those off, I can't remember. So as long as they're good, productive comments. Awesome. Thank you.